In this learning target, we're going to be able to represent and interpret data with dot plots. So what do we need to know? Dot plot is a graph that displays the frequencies of data values using dots above a number line. Dot plots are best for small data sets whose values are integers. So here's an example. We have the number of books of each of the 21 customers at a used book sale, and then we have the list of all 21 customers. So to represent that data in a dot plot, you can see here, you would take each data point and you would put a dot to represent that piece of data. So I've got my number line. I notice where I'm starting. So I'm starting at 2 and ending at 11. So I want one above and one below. And then I just represent each data point with a dot. So 3 gets 1 dot, 4 gets 1 dot, 5 has 2 values, so it gets 2 dots, so on and so forth. So some observations, there were 21 customers. So on the dot plot, there will be 21 dots. The value of 2 occurs once. So there's one value above the number 2, and that means that one customer bought 2 books. The frequency of 7, however, is 3. So 3 customers bought 7 books each. That's what we have 3 dots. And then the frequency of 10 is 4. So 4 customers bought 10 books each. That's how we interpret that dot plot. A couple other things we want to talk about dot plots are the distributions of the dot plot, or the shape. So you can have a uniform distribution, you can have a bell-shaped distribution, and both of these are considered symmetric distributions. So if it's uniform, you're going to be able to kind of draw a rectangle around your data. Now keep in mind, real data is very, very, very rarely going to look like this, where you actually have a perfect rectangle. You might be missing a dot here or there, but the relative shape is still uniform. Same with the bell-shaped distribution here. We've got our nice bell curve. But keep in mind, again, very rarely will you have something quite so perfect. Now, other types of data situations that might be present are when we have skewed distributions. So here, notice how the data points are lower on the left side of my number line than they are on the right side. And then over here, the ones that are skewed right, they're lower on the right side than they are the left side. So in skewed distributions, one side has lower frequencies than the other side. And the direction of the skew is toward the short end or the tail. Okay, so here's the short end over here before I rise. So that's why we say this is skewed left. And here my short end is towards the right. My data is getting smaller on the right side. Now, using those distributions, we can also describe the relationship between the mean and the median, depending on the distribution of our graph. So if we have a distribution that's approximately symmetric, that our mean is going to be equal to the median, or it's going to be approximately equal, because most likely, like I said before, my data is not going to be perfect, but they're going to be really close to one another. As opposed to if I had something skewed left, like I do here, notice how my mean is being pulled closer to that tail. Okay, it's these values over here are they're pulling that mean closer to them. So my mean value is going to be less than the median because my data on the left tail is smaller data. So my mean is going to be smaller, as opposed to on a graph where we're skewed right. Now my mean is being pulled towards the tail on the right side, and these values are larger. So my mean is going to be greater than the median. So let's answer a question based on this information. So remember that the direction of the skew is toward the mean. So here are the numbers of applicants that applied for a position each day that the employer accepted applications. We have the set of data, but nicely they gave us the dot plot. So we can just interpret the dot plot. So describe the shape of distribution. It might be helpful if you kind of take a pen or pencil and just kind of see what the shape's going to look like. Here I can see that I have a lot less over here on the left side than I do on the right side, which would tell me that we're skewed left. Okay, if you have lower data on one side versus the other, that's going to be the direction of your skew. So if I'm going to describe the relationship between the mean and the median, well, remember that the mean is pulled towards the direction of the skew. It's going to be pulled left. And the values on my number line towards the left are smaller. So the mean is going to be smaller than the median. Now in example 2, this one is a little bit different than what we just did, so you might just want to hang out and watch me through, but if you want to try to give it a go, you are free to do so. about what percentage of the puppies were either 3 or 4 months old. Okay, so I have this set of data here. The dot plot shows the ages of puppies that were adopted from a shelter during one weekend. I want to know which puppies were 3 and 4, and I want to know the total percentage. Okay, so here's how we define a percentage. We find the part, and we divide that by the whole, or the total, and we multiply it by 100. So right here, I've got my puppies for the part. I know I have 5 3-month puppies and I had 4 4-month puppies that were adopted. That would give me a total of 9. Now I'd also need to find the total amount. So I could go through and write the totals of each of these values here, and then we could add them all up. So the number of 3 or 4-month-old puppies was 9, and then the total number of puppies is the total number of dots, which, if we add these up, gives us 29. When I divide, I get 0.31, but remember we have to multiply that by 100 to get a percent, so about 31% of the puppies were either 3 or 4 months old. Now we want to use the distribution of data to describe the relationship of the mean and the median. Well, if I look at this dot plot, I notice that it's relatively uniform. It kind of makes that rectangle shape around the data. And when that happens, my data is symmetric, which means that my mean and the median are going to be about the same value. All right, if you would like some more information on this topic, you can check out the Learning Target spreadsheet for additional resources, videos, and practice.